Welcome to The Explainer. Today, we're popping the hood on software engineering. We're going to look at how a simple line of code turns into a product that basically runs our world. And, what gives this whole field its incredible market value?
So let's start with a really basic truth. Software isn't just a niche thing anymore. It's the invisible backbone of, well, everything. How you bank, how your food is grown, it's just everywhere. And that's exactly why understanding how it's all professionally built is more important than ever. All right, here's our game plan for this explainer. First, we'll figure out what software engineering really is. Then, we'll check out the blueprint they use to build stuff, look at the skills an engineer actually needs, and finally, we'll connect all those dots to its real-world value.
Okay, let's jump right into this first part. When we say software engineering, what are we actually talking about? It's a term that gets thrown around a lot, but what it really means is super important.
See, at its heart, software engineering isn't just about hacking away at a keyboard until something works. It's a formal discipline. Think of it this way. Pretty much anyone can nail some boards together and make a shed, right? But if you want to build a skyscraper that's going to last for 100 years, you need engineering. You need a systematic, disciplined, and measurable process.
And this is why it's so important to see how it's different from computer science. Computer science is all about the deep theory, the fundamentals, what's even possible. Software engineering, on the other hand, is the applied work. It's taking all that theory and using it to build reliable, high-quality products for the real world. It's basically the bridge from an idea to reality.
So how does a cool idea actually become a piece of software you can use? Well, turns out there's a blueprint for that too.
And that process is called the Software Development Lifecycle, or SDLC for short. It's really just a roadmap that guides a project from a fuzzy concept all the way to a finished product and even beyond. It brings some much-needed structure to what could otherwise be a pretty chaotic mess.
What's so smart about the SDLC is how it breaks this huge task down into 7 logical, manageable chunks. Each step answers a really fundamental question, making sure nothing gets overlooked. From the very first, why are we even building this, all the way to how are we going to fix and change it down the road.
Having a great blueprint is awesome, but it's totally useless without a skilled builder. So what specific skills does an engineer need to actually pull this whole life cycle off? I'll tell you, it's a lot more than just knowing how to code.
I mean, look at this toolkit. It's incredibly diverse. Of course, you've got the technical skill of actually building the software, but it's how that skill works with everything else that's so important. You could have the most brilliant architecture, but if you can't communicate it to your team or manage the project schedule, it doesn't matter. That's why things like communication and teamwork aren't just nice-to-haves, they're absolutely essential.
And this just shows you the depth of the craft. On the technical side, engineers follow established principles like SOLID. Now, you don't need to memorize what that stands for. The big idea here is that this isn't about just making code work right now. It's about building it so that it's easy to understand and flexible, so it can be maintained and updated for years. And that directly translates into business value, right? Lower costs, and the ability to change things up in the future.
Which brings us right to our final section, the payoff. How did this discipline process and this really broad toolkit actually translate into real, tangible value out in the marketplace?
Well, first off, this discipline is a launchpad for a huge range of high-demand careers. Graduates aren't just coders, they can specialize and become architects, project managers, security experts, or user experience designers. The whole process creates specialists for every single step of the way.
And we see this specialization creating value every single day in the freelance market. Here are just a couple of examples of developers in Addis Ababa, Ethiopia, who are turning their very specific skills, like 3D websites or UI/UX design, into successful businesses, building projects for clients all over the world.
But here's the real secret to its market value, and it comes down to a really important shift in education. See, modern software engineering programs aren't just tech schools anymore. They are now deeply connected with the principles of business.
So, right alongside learning about algorithms and data, students are now learning how to write a business plan, estimate costs, understand marketing, and deal with intellectual property. They're not just being trained to build a thing. They're being trained to understand its place in the market and how to make it profitable.
And that leaves us with this final thought. Software engineering has really grown up. It's gone from a purely technical job to this powerful engine for innovation and for commerce. It's a field that mixes science, management, and business to solve real problems. The only question left is,